radio controlled boat. So this here is the remote. So it starts with these 4 push buttons here, which are wired to these 4 pins on the Arduino. So when a push button is pressed, it sends a logical low to the Arduino. The Arduino interprets the pins that receive the logical low and sends outputs from these 4 other pins here, which are connected to the HT12E encoder here. And the encoder receives the output from these 4 pins of the Arduino, and it takes that parallel data and converts it into serial data that is suitable for our RF transmitter here, which takes the serial data that's been converted or encoded by the encoder and sends it through radio waves to the transmitter.
LEDs represent binary signals that get sent in through the encoder, and these LEDs represent essentially 4 bytes that get sent through radio frequencies, which can be shown through here, the oscilloscope. The oscilloscope is getting very noisy signals because it's being sent multiple times every second, because it's running at 433 megahertz. And as you can see from the oscilloscope, or what you can roughly see is there are 12 bits that get sent through the transmitter. 8 of them, the last 8 are address bits, and the thick ones represent zeros, and the thick ones are essentially these blue wires and these orange wires, which represent essentially a password that gets encoded into the radio frequencies. And the other 2 bits here, and the last 4 bits represent instructions that get sent over through radio frequencies. And this short bit that gets shown on the oscilloscope represents a 1, and this is another 1, which correlates through to this blue light being on and this red light being on, and this blue light being on and this red light being on, and that then gets sent over to the oscilloscope readings for the receiver, and gets decoded through this decoder into the last 4 bits, which represent the 4 signals coming out of the decoder that Kaiser talked about. And as you can see here, there's a lot more interference, and it's a lot harder to see what specifically the address bits are, and also what the instruction bits are. But the resistors control on the decoder and encoder control how fast the encoder and decoder encodes. And since the resistors are specifically set to the frequency that the transmitter is transmitting in, it's able to parse it somewhat. However, because of this noise, the motors are turning on and off, and this solution can be fixed through soldering capacitors onto the motors. However, we couldn't find any solder in the lab, so we're just going to put that in the lab report for future improvements. The first button represents going forward. So depending on the shape of the propellers of the boat, they're both moving in the same direction, as shown by the tape. Additionally, the blue light represents a signal being received from the remote. And we believe that there's a lot of interference in this room currently. So it's getting choppy signals. And when we press this, you can see here that the direction of both of them spinning changes, and they're currently both getting signals from the receiver, indicated by the blinking light. And
So this would be backwards, moving backwards since they're both moving in opposite direction as the forward button.
And then left and right.
Which would cause it to turn like either left or right. In this case, I think it would be like right.
And then the final button.
Direction as the one that as the right button, so that would cause it to turn left.